Hello students, good morning. Now we are discussing some more problems that is depend upon the topic of chemical equilibrium. Now the first problem is for an equilibrium reaction, the rate constant for the forward and backward reactions are 2.38 into 10 to the power minus 4 and 8.15 into 10 to the power minus 5 respectively. Now calculate the equilibrium constant, that is Kc or Kp, for the reaction. Now we will discuss the solution of this problem. As we know that equilibrium constant, that is the Kc or Kp, we are having the physical state of product and reactant are in the gaseous state, then using Kc, and if the physical state of reactant and product are the gaseous, then using the Kp. So here is the Kc equals to Kf and Kb. The rate constant of forward reaction, this will be equals to rate constant of, this will be the ratio of forward upon backward. Here is the Kc equals to rate of forward reactions, that is 2.38 into 10 to the minus 4 upon rate of the backward reaction, that one 8.15 into 10 to the minus 5. By solving of this value, we are getting the answer, that is Kc equals to 2.92. Now the second question is, in a reaction between H2 and I2 at a certain temperature, the amount of H2 and H2, I2 and HI at equilibrium were found to be 0.45 mole and 0.39 mole and 3 moles respectively. Calculate the equilibrium constant, that is the Kc or Kp, for this reaction. Now, first we are writing the equation. The reaction will be, according to the question, in a reaction between H2 and I2. So here the reactant is H2 and I2. They gives the product of 2Hi. Now, Kc of this equation equals to Hi square upon H2 into I2. And by putting the value, we are getting the answer, that is Kc equals to, here the concentration of Hi. What? In the question, the moles of Hi is 3 and concentration means moles per liter. So we are assuming that volume is Vml or V liter. So the concentration equals to moles per liter. Here the concentration of Hi becomes, moles of Hi is 3 and volume becomes V. Similarly, concentration of H2 equals to, moles is 0.45 divided by V, and concentration of I2 equals to 0.39 divided by volume. Now putting the value, we are getting the answer, the Hi is 3, but here the square of Hi, so we can write 3 by V into 3 by V upon concentration of H2 is 0.45 upon volume into I2, that one 0.39 upon V. Now by the cancel out of V and V, by solving the equation, we are getting the answer of Kc equals to 51.28. So this is the answer for this reaction, means equilibrium constant for this reaction is 51.28. Now in the third problem, reaction, that is N2 plus 3H2. It gives the ammonia, that is 2NH3. Now the partial pressure of N2, it becomes 0.80, H2 equals to 0.40 atm. It's the value of pressure. The total pressure of the system is P total equals to 2.80 atm. Now finding the Kp for this reaction. Yes. So first we are knowing that Pn2, here is the partial pressure of N2 becomes 0.80 and H2 is PH2. It becomes 0.40 atmosphere. Now Pn2 plus PH2 plus PNH3, that is the total pressure is 2.80 atmosphere. Now Pn2 is 0.80 and PH2 is 0.40 plus PNH3 equals to 2.80. Now PNH3 equals to 2.80 minus 0.80 plus 0.40, that becomes 0.80 and 0.40, that will be 1.20. Now subtracting the value, we are getting the answer PNH3 equals to 1.60 atmosphere. PNH3 equals to 1.60 atmosphere. Now putting all the value in the equilibrium reaction, the reaction is Kp equals to NH3 square, since coefficient of the NH3 is 2, upon N2, which no coefficient, and H2 is the cube, since the coefficient is 3. Now Kp equals to, here is the NH3 means, what's the value of NH3? That will be 1.60 square, and the for N2 is 0.80 and V2 is H2 becomes H2 cube means 0.40 cube. Now solving of this, we getting the answer 50. So the equilibrium constant for this reaction is 50.